Alright, so as we move down, we're going to finish up this last part with number 10. And we're going to fill in the chart to examine what does it mean for an atom to be an isotope, right? And we're going to look at hydrogen specifically. So click on here to show your work, and we are going to put this down. And if you want to look at it a little closer, you can use this little zoom in button once again, right? And then use this hand to kind of move stuff around. Alright, so there are three isotopes of hydrogen. Okay, first one right here is a hydrogen by itself, and then this one is called deuterium, and then the third one is called tritium. Tritium, I think that's how I say it. All right, so you're going to fill in the chart for three isotopes of hydrogen, and we're just going to examine the protons, neutrons, and electrons that we have done before, just looking at the pictures this time. All right, so let's use the text box item. So the number of protons, right, that stands for P. We see that hydrogen, right, the normal hydrogen atom, only has one. And it doesn't have any neutrons in the middle, so that's going to be 0. And then it only has one electron on its first shell right there, so I'm going to put a 1 right there. Alright, deuterium, which is the second isotope of hydrogen, as we see here, it only has one proton. We'll put 1 there. And then there's an added neutron there. Right, so put it right there. As you can see here, the atomic mass increased by 1, so now it's 2. So 1 plus 1 is 2. And then it still has 1 electron, so we just put 1 right there. Now, tritium is the third isotope of hydrogen. It still has 1 proton, but this time it has 2 neutrons. Right? So 2 plus 1 is going to equal 3, which is my atomic mass, and how heavy an atom is in atomic mass units. And then it still only has 1 electron. Okay, so we should see a pattern here that isotopes, right? What do you think that might be looking at this pattern? So let's use this hand signal right here, and we're going to just type in the patterns we see. Zoom out a little bit. All right, so what structural characteristics do all three hydrogen atoms have in common? All right, so if you look at that, you should see that they have, so you use the text box right here, type it in. Okay, they have the same number, okay, of protons, electrons, okay, they have the same atomic number, right? See here, they both have an atomic number of 1 on the bottom. Okay, and they're also the same element. They were all hydrogen, right? Because as you see here, it's still H as this chemical symbol. So how does one isotope of hydrogen differ from another isotope of hydrogen? Okay, so we see that the protons and electrons stay the same, but the difference we see is in the the number of neutrons. This is my difference right here. Okay, so let me type that in. Press text box. Okay, there is a there is a difference in the number of neutrons, and then they also had different atomic mass, because now you have more neutrons involved in the nucleus. Right, so once again, remember this, right? We've talked about this before. What does the atomic mass tell you? Atomic mass tells me this color, purple. Yeah, atomic mass tells me the number of neutrons and protons. Atomic number, on the other hand, which is the bottom number, only tells me the number of protons, and you see electrons and atoms. Okay, and then looking at all this, what does it mean for an atom to be an isotope? Okay, what does that mean? So as you can see here, right, it's the same atom, but it just has different number of neutrons. So each atom has unique, different, I guess, different types of isotopes based on their neutrons, and they still have very similar properties, but just very small differences. Okay, so atoms of the same elements with the same atomic number but different atomic mass because of the different number of neutrons. Right, so that's the main gist, right? Isotopes are just atoms with different number of neutrons. Okay, and you're gonna learn later that when you have like nuclear decay or nuclear power plants, that's when the neutrons of different isotopes kind of like fall apart, and that creates energy. Okay, so pretty neat. If you want to know the reason why atomic mass is like 22.99 and not like 23, is because there are many isotopes for each element. So there's like carbon 6, carbon 7, carbon like different number of neutrons, and you kind of find the average of all the isotope masses, and then kind of just round them up, or leave it as this kind of average value. Okay, so we're not going to learn about weighted averages and how to calculate the averages of isotopes, but just know that an isotope is an atom with a different number of neutrons.